On coral reefs, identity is not fixed. Within a single lifetime, some fish change sex, once or even multiple times, responding to social shifts in ways that challenge conventional biology. Among reef-dwelling species, one of the most remarkable examples of biological flexibility is found in the clownfish, Amphiprioninae.
Clownfish are sequential hermaphrodites, meaning they begin life as one sex and can later change to another. Specifically, they exhibit protandry, a system in which individuals are born male and may later become female.
Within a typical social group, which lives among sea anemones, there is a strict size-based hierarchy. The largest individual is the dominant female. The second largest is a breeding male, and all remaining members are non-breeding males. If the dominant female dies or is removed, the breeding male undergoes a transformation and becomes female. At the same time, the largest non-breeding male matures into the new breeding male. This transformation is not superficial. It involves profound changes in gonadal structure, hormone production, and behavior. Such flexibility allows the group to maintain reproductive continuity without the need to find new mates in a complex and competitive environment. The transition observed in the clownfish is controlled by precise endocrine mechanisms. At the core of this process is a shift in hormone balance. Male clownfish produce higher levels of androgens, while females produce estrogens, particularly estradiol. When the dominant female is absent, the breeding male experiences a reduction in androgen levels and a corresponding increase in estrogen production. This hormonal shift triggers the restructuring of the gonads. Testicular tissue gradually degenerates, while ovarian tissue develops and becomes functional. The process may take several weeks, during which behavioral changes also occur. The transitioning individual adopts the role and behaviors associated with a dominant female, including increased aggression and control over the group.
Neuroplasticity plays a role as well. Brain regions associated with reproductive behavior adjust to support the new social and biological role.
This coordinated transformation demonstrates the integration of hormonal, anatomical, and behavioral systems. While clownfish typically change sex only once, other fish species are capable of reversible sex change, switching between male and female multiple times during their lives. A notable example is the bluehead wrasse, Thalassoma bifasciatum, a small reef fish found in the Atlantic Ocean. In this species, individuals are born female. When the dominant male within a group disappears, the largest female rapidly transforms into a male. This transformation can begin within hours and is often completed within days. Behavioral changes, such as courtship displays and territorial defense, may occur even before the anatomical transition is fully complete. In some populations, environmental or social fluctuations can lead to repeated shifts in dominance, creating conditions where individuals may undergo multiple sex changes over time. This capacity reflects a high degree of biological plasticity, allowing individuals to adapt dynamically to social structure. Sex change in these fish is not random. It is triggered by social cues, particularly the absence or presence of dominant individuals. Visual signals, physical interactions, and behavioral hierarchies all contribute to the regulation of sex change. In the clownfish, the dominant female maintains her status through aggressive behavior that suppresses the development of other individuals. When this suppression is removed, physiological changes begin almost immediately in the next individual in the hierarchy. Environmental factors can also play a role. Population density, resource availability, and habitat structure influence group composition and stability. In species like the bluehead wrasse, the removal of a dominant male, whether by predation or other factors, creates an opportunity for another individual to assume that role. This system ensures that reproductive capacity is maintained, even in fluctuating environments. The ability to change sex provides significant evolutionary benefits. In environments where mates are scarce or group structure is tightly organized, fixed sexes may limit reproductive success. Sequential hermaphroditism allows individuals to maximize their reproductive potential under varying conditions. For example, in species where larger size confers an advantage in reproduction, it may be beneficial to function as one sex when small and another when larger. In clownfish, larger individuals are more successful as egg-producing females, while smaller individuals function as males. In wrasses, dominant males control access to multiple females, making male status advantageous only for individuals large enough to defend territory. By aligning reproductive roles with size and social position, these species optimize their chances of passing on genes. This flexibility represents a highly efficient solution to ecological constraints. The existence of species, such as the clownfish and the bluehead wrasse, challenges simplified views of biological identity. In these organisms, sex is not a fixed characteristic determined at birth, but a dynamic trait that can change in response to internal and external conditions. This phenomenon highlights the diversity of reproductive strategies in the natural world. While mammals typically exhibit fixed sexual differentiation, many fish and invertebrates demonstrate a wide range of flexible systems, including simultaneous and sequential hermaphroditism. Understanding these systems provides insight into the adaptability of life and the ways in which evolution shapes reproductive strategies. It also underscores the importance of studying a broad range of species to fully appreciate the complexity of biological processes. In coral reef ecosystems, where competition is intense and conditions can shift rapidly, flexibility becomes a key factor in survival. Thank you for watching. Subscribe for more explorations into the diversity of life, where even identity can shift in response to the changing balance of nature.